Hello friends, in this video we are going to discuss about the common collector configuration of the BJT. That is, we are discussing the CC mode. And for this CC mode, we are taking a PNP transistor. So let us draw the PNP transistor first. This is the collector terminal, and this will be the emitter terminal, and this is the base terminal. So we can write here emitter, collector, and base. Now we will give a voltage at the collector terminal as negative potential like this, because this is an P in P transistor, so collector should be given negative, and in the emitter we will connect a RE resistance here, and it will be connected to the positive terminal of the voltage. So here it is negative and here it is positive. In the base part, we will give a input signal like this. So there will be an input signal I at this point. So we can say that IB current direction will be here IB current, and there will be an IC current flowing, and there will be an I current also flowing. If I take the I current direction in the inward, I can take this. So the output voltage will be taken across the emitter. So this is the output voltage where the point will be taken. It must be remembered that in the common collector configuration, the output voltage is taken from the emitter terminal. So this is the positive and this is the negative terminal. So in this case, you can see that the circuit is basically the same as the circuit of the common emitter configuration, with the exception that the load resistor is in the emitter circuit rather than it is in the collector circuit. Now if we continue to specify the operation of the circuit in terms of the currents which flow, the operation of the common collector is much same as the emitter configuration. Now let us see what are the input parameters that we have right now. So the input parameters that we have right now in this CC configuration is the input current, that is IB, and the input voltage, that is VB. Similarly, if we write the output parameters, so the output parameters here we can see the IE current and the VE voltage here right now. So if we draw the input characteristics, the input characteristics can be drawn like this. So in the x-axis of the input characteristics, we will get the VEB voltage, and in the the y-axis, we will get the IB current. Now we know that, and for these input characteristics, the VEC value must be constant. Now, for finding the input characteristics, we can write that the VCB value can be written as VCE minus VBE, and VBE can be written as further as VCE minus VCE. So from this equation, we can find that the VEB value will be the VEC value minus the VBC. So if the VEC value is maintained in a constant value, and VBC is increased, then the voltage VEB will continuously decrease. That means for constant value of VEC, that means if VEC is constant, then if we increase the VBC value, then the VEB value will continuously decrease. Due to this, the carriers flowing from the emitter to the base will be reduced because the emitter base potential is decreased. So we can say due to this potential decrement at the VEB, we can say that the carriers which are flowing which are flowing from emitter to base will be reduced will be reduced. This causes a decrease in the number of recombination in the base. So we can say due to this, the recombination in the base will be decreased. If the recombination in the base will be decreased, then the base current will further decrease. So we can say that the base current will decrease with VEB increment. So we can say that the graph will look like this at this point, and at this point, if we define the voltage, example voltage, if let us take it is 4.2 volt and it is 5 volt, then at this point the VEC voltage will be 5 volt. Let us assume this 5 volt. So this will be the input characteristics of the common collector configuration. So let us see the output characteristics of the common collector configuration. So the output characteristics of CC mode means we have to plot IE versus VEC while maintaining the IB constant for CC configuration, and this configuration, that is this characteristics of VEC and IE will be same as that of the CE mode. So in the CE mode, the output characteristics is same as the CC mode for different value of IB1, IB2, IB3 and IB4, where IB4 will be less than IB3, less than IB2, less than IB1. So this will be the output characteristics of a CC configuration which is similar to the CE configuration. So what are the properties that we can find from this CC configuration. That is, first property that we can find here is it will have highest input resistance. Generally, the value of the input resistance of the order of 50 kilo ohm to 500 kilo. The second property we can have here is the lowest output resistance, generally less than 100. The third property is that it will have a highest current gain. Property that we can find that it will have a lowest voltage gain value and also the lowest power gain value. Emitter, this circuit, common collector mode circuit, is generally called as the current control voltage source, or sometimes it is called as emitter follower circuit. And this emitter follower circuit is nothing but current control voltage source. So what are the application of this common collector circuit? Let us see the applications of this common collector circuit will look like this, that it is used as a audio frequency power amplifier, audio frequency power amplifier. The common collector circuit is also used as impedance matcher. Common collector configuration is used for voltage sweep circuit. There are so many applications. Sometimes it is also used as bootstrap emitter follower also. Bootstrap emitter follower. There are several applications of this, and the DC current gain of the CC mode is nothing but the gamma value, and gamma value is IE by IB, and it will be equals to 1 plus beta, where beta is the current gain of the C. This is all about the common collector configuration of bipolar junction transistor. Thank you.